In geometry, a circle is one of the most fundamental shapes we encounter, but what exactly defines a circle? We begin with a single fixed point in space. This point will serve as the center of our circle, the anchoring point from which all measurements will be taken. What makes a circle special is that every point on its boundary has exactly the same distance from this center point. This constant distance is what we call the radius. Let's place several points around our center, each exactly the same distance away. These points will lie on what will become our circle's circumference. To visualize the equal distances, let's draw lines from the center to each of these points. These lines represent the radii of our emerging circle. The red markers highlight that each radius has identical length. No matter which direction we move from the center, as long as we travel exactly this fixed distance, we'll reach a point on the circle. If we were to plot every possible point that sits exactly this fixed distance from the center, we'd trace out a perfect circle. The smooth curve emerges naturally from this distance constraint. These radial lines demonstrate the key structural property of circles, the constant radius. Each line connects the center to the circumference along a different path, yet all have exactly the same length. This constant distance, which we denote with the letter R for radius, is the defining parameter of any circle. It completely determines the circle's size. From this geometric understanding, we can derive the formal mathematical definition of a circle. This elegant definition, the collection of all points at the same distance from a center, is what gives rise to the circle equations we use in coordinate geometry. The standard and general forms of circle equations are simply algebraic expressions of this fundamental property. The key takeaway is that a circle is defined by its constant radius property. Every point on the circle is exactly the same distance from the center, no more, no less. Let's explore how the equation of a circle is derived from the distance formula. The distance formula is fundamental to understanding why a circle's equation takes the form it does. Here's a circle with center at the point 3, 2 and radius 2. Notice how every point on this circle is exactly 2 units away from the center. The center of any circle can be represented by the coordinates h and k. These variables are commonly used in the general form of a circle's equation. In our specific example, the center coordinates are h equals 3 and k equals 2. These values will be substituted into our final equation. The radius